Going to explain about the definitions of a gradient of a scalar field, divergence of a vector field, curl of a vector field, and also directional derivatives. So let us see first one, gradient of a scalar field definition. If phi of xyz is a continuously differentiable scalar function, then gradient of a phi is defined as this whole function. Observe, if phi of xyz is a continuously differentiable scalar. What is the meaning of continuously differentiable scalar function? Means this scalar function must exist a derivative. Okay, phi of xyz, you know that phi is nothing but a scalar function. Phi of xyz is a scalar. Then the gradient of this scalar is defined as a dou phi by dou x into I plus dou phi by dou y into j plus dou phi by dou z into k, and it is denoted as a grad phi. In shortcut, grad, grad only, grad phi, that is, or it can be denoted as a del phi also. Both are same here, grad phi or a del phi, that is equals to. This operator is on a scalar function. That means you know that a del function, that del is nothing but dou by dou x into I plus dou by dou y into j plus dou by dou z into k. This del operator on a scalar function that defined as a dou phi by dou x into I plus dou phi by dou y into j plus dou phi by dou z into k. Observe this whole function, it includes here I, j, k, then it is obviously vector quantity. Therefore, gradient of a scalar function is always a vector quantity. Phi is a scalar function, grad of a scalar, that gives here vector quantity. Similarly, next we have another one definition, divergence of a vector field. Observe here, if vector A of xyz is a continuously differentiable vector function, then the divergence of vector A is defined as divergence of A is equals to del dot A, del dot vector A. Okay, divergence means del dot vector A, del function, we know that del operator as a dou by dou x into I plus dou by dou y into j plus dou by dou z into k, dot product with vector A. Consider vector A generally as a a1i plus a2j plus a3k. The dot product between these two vectors, there is a dot product between these two vectors, that implies coefficient of I is here dou by dou x, coefficient of I is here a1. Therefore, it becomes dou a1 by dou x plus dou a2 by dou y plus dou a3 by dou z. Here coefficient of a z is dou by dou y, here coefficient of a z is a2, dou by dou y of a2, dou by dou y a2 plus dou a3 by dou z. Observe this one, this is a without a ijk term, then obviously this is the scalar quantity. What we had taken here, vector A, divergence of vector function, that gives the scalar quantity. Okay, so divergence of vector A is denoted as a div of vector A. In shortcut, it is denoted as div or del dot vector A. Del dot vector A. Divergence means that is always a dot product. Del operator, you know that del operator definition, dot product with vector A, that gives a dou a1 by dou x plus dou a2 by dou y plus dou a3 by dou z. This is the purely scalar quantity.